Hello Pre-Cal fam, and here is a quick video with some selected problems that will help you review for our quiz. You should also see some of the other videos and animations that I have put from Virtual Nerd also on the What's Happening website. So here goes. Write an equation of a line that passes through a given point and is perpendicular to a given line. So the first thing we need is the slope from the given line. So 3x plus 5y equals 10. 5y equals negative 3x plus 10. Divide by 5. Y equals negative 3/5 x plus 2. So we need that slope. And if we want a perpendicular line, then we need the opposite reciprocal of that slope. So our perpendicular slope, and yes, that upside down T is the symbol for perpendicularity. So a perpendicular slope will be positive 5/3. Positive 5/3. So this is our point. And as I mentioned in class, I always want to see the point slope form first. So y minus 3 equals 5/3 times x plus 7. So this is the point slope form. Secondly, I want to see the slope-intercept form of the line. So from here, we're going to solve it for y. So y minus 3 equals 5/3 x plus 35/3. 5/3 times 7, 35/3. Next, we'll be adding 3. So watch this little trick. So if we are adding 3 on the left, we will add 3 on the right. And I took the liberty to go ahead and get that common denominator. 9/3 is equivalent to the 3 right there. So here we go. Here's our second part of our answer, our slope-intercept form. Y equals 5/3 x plus 44/3. So new equation of a new line in slope-intercept form. So once again, point slope form followed by slope-intercept form. Next, this is a piecewise function, and yes, we will have to graph, not by hand. Remember, this quiz is on MathLab, so most of it will be multiple choice, so you will have to graph a piecewise function and pick the correct answer via multiple choice, but this one is just an evaluation of a piecewise function. So remember, a piecewise function divides the domain into two different intervals, everything strictly less than 1 and then everything greater than or equal to 1. So what is g of 0? G of 0 falls into the first interval, therefore we're going to use the first piece of the function. So negative 3 times 0 plus 1, that is 0 plus 1, that is 0. So g of 0 is 1. Next, g of 3. 3 falls into the second interval. So g of 3 is 2 times 3 minus 4. That's 6 minus 4, that is 2. Negative 10. Negative 10 falls into the first interval. Negative 3 times negative 10 plus 1. That's 30 plus 1, that is 31. So that's evaluating a piecewise function. A piecewise function is nothing more than a set of two different directives telling us what to do with different domain values. Next, find and simplify the difference quotient. So here's the difference quotient. Yes, you need to know it. And this, of course, is in terms of the g function because that's what's given. And, oh, I forgot to say that h could not be 0. That's what's supposed to be there. H cannot be 0 for the given function g of x equals negative 6x plus 1. This is all about proper substitution, evaluation, and following order of operations here. So first thing we want, g of x plus h. So wherever we see x, we are plugging in x plus h. Let's do it. So negative 6 times x plus h plus 1. Okay, minus g of x. So all of g of x is going in for g of x. This is all about substitution and following directives. So minus negative 6x plus 1. Note I'm using brackets here because this is a good time to use grouping symbols. Of course, this is all over h. I think I can move to the right here. So next, distribute that negative 6, and we get negative 6x minus 6h plus the 1, and then minus negative 6x plus 1 all over h. Let's keep going. And next thing I'm going to do is distribute that negative 1 into that second set of brackets. It's the same thing as right there. So first set of brackets, and I'm going to go ahead and drop the brackets because after I make that distribution, I won't need them anymore. Negative 6x minus 6h plus 1 plus 6x minus 1 all over h. Remember, when we're doing the difference quotient, we're anticipating that a lot of stuff is going to cancel because that's what's supposed to happen. So what remains? Well, negative 6x cancels with positive 6x, and positive 1 cancels with negative 1. So we are left with negative 6h over h. Now the h's cancel, and we get negative 6. The difference quotient for this linear function is simply negative 6. Next, what we did in class today, find the average rate of change of the function h of x equals negative 6x plus 5. Now, we graphed a function similar to that in class today. If we were to take a look at that graph, it would look something like this. So first of all, 6x plus 5 greater than or equal to 0. We're just finding the domain. 6x greater than or equal to negative 5 divided by 6 divided by 6. X is greater than or equal to negative 5 6. So if negative 1 is right there, negative 5 6 would be about right there. And this particular graph would look like something like that if we were to graph it. And that's just a very rough estimate. It's just a nice, simple curve up. Remember, square root functions do have a domain restriction. So that's why we have a starting point there and then everything to the right. Now, we're after the average rate of change. So when x sub 1 equals 10, and 10 would be probably about right there, and 12 would be about right there. We can't even see what's going on with the graph. So it's pretty flat. So I'm not anticipating a very steep rate of change for that secant line. So average rate of change, of course, here's the formula. This is the h function, so I'll do it in terms of h. The average rate of change, delta y over delta x equals h of x sub 2 minus h of x sub 1 over x sub 2 minus x sub 1. So let's plug in everything. So first of all, we've got h of x sub 2, so that's h of 12 minus h of 10 over 12 minus 10. Moving to the right, h of 12, go to the function, evaluate the function when x equals 12. So that is going to be the square root of 6 times 12 is 72. 72 plus 5 is 77. That radical does not reduce. Leave it just as it is. H of 10. H of 10. 6 times 10 is 60. 60 plus 5 is 65. Square root 65 over 12 minus 10 is 2. So this is the exact rate of change. If we wanted to consider what it might be and we could estimate here, the square root of 77 is really close to 9. So I'll estimate about 8.7. The square root of 65 is just a smidge above 8. So we'll say 8.1, and that's pretty generous. All over 2. So if we're getting an estimate here, and listen, this is fine. I just want you to think about it as it relates to the graph for just a moment. This would be 8.7 minus 8.1.6 over 2, which would be about 0.3. That is up 3 over 10 if you want to think about it in terms of a slope. That's a pretty flat slope. Think about it. Up 3 over 10. That would be a not very steep secant line. So does our answer make sense? Yes, and we always want to think about if our answer makes sense. But again, ladies and gentlemen, this is the exact answer, and this is what I'll be looking for. Next, finding domains and ranges, which we hit on pretty hard in class. The domain of this function, remember the domain is read from the left to the right, and the domain has everything to do with the x-axis. Domain and range will be given in interval notation. So our domain goes to the left forever. So the domain here starts at negative infinity, and it goes up to negative 1. It goes up to negative 1. That circle is filled, therefore we will use a bracket. Then we have a break in the domain, which does make this, of course, a discontinuous function. So from here, union, then it starts again at 2, but the circle is open. And if that circle is open, we will close that interval with a parenthesis. It does continue on to the right forever, so from 2 to positive infinity. That is the domain. The range, remember, this is a discontinuous function. There is also a break in the range. The graph does not exist between 0 and 1. The range has everything to do with the y-axis. So our range here, it does go down forever. So it does start at negative infinity, but it goes up to 0, closed. And then it starts again at 1, but it's open, so parenthesis 1, and then it goes up forever to positive infinity. Domain, range. And I think we must be done because now we're to algebra.